Hi, my name is Olivia, and in this video I will be introducing you to the topic of strings. The aim of this video is to maybe teach you something new, or maybe just solidify a knowledge you already had about strings. So, what are strings? Strings are actually quite complex in C, and they can come in many different forms. But for our purposes, we will just assume a string is an array of characters. So as an array of characters, these characters can be heaps of things. They can be letters, they can be numbers, they can be symbols, they can even be weirder things like the spaces between words, and they can also be new lines. So when you press the enter button. So knowing all of this, these characters are all connected together and they are organized into an array. So let's consider the phrase or the string hello world. So we have, I'll just do that, hello world. So if we wanted to organize this into a string, into an array, it would look a little something like this. Okay, let's fix that. Hello, and I really hope this fits. Space world. Okay, so it fits. Yay. So as you can see here, each character is organized into its own little box in the array. So in a normal array, we've got sorry, it's covering my head, I'm sorry. So in a normal array, each element is an integer. But here they're all type char. So I'm just going to write char up here. So each one of these is a char. Char, char, char. And then each indice is underneath. I'll write that. So as usual, it starts at the 0th index and goes up from there. So 0, 1, 2, 3, 4, and so on. So just to solidify that knowledge again, so the 4th index is actually the 5th letter. So as we know, O is the 5th letter in hello, but it's actually the 4th index. Alright, so knowing all of this, there's actually something different about strings. So what's different about this to a normal array? And that's this null terminating character here. So this is a very special character, and it's actually what makes a string a string. So C will read in each element of this array, and it will be like, yep, that's a character, you're a character. It'll keep going until it gets to this null terminating character. And when it gets there, it's like, okay, the string is over, we're done now, because this means the end. And that's actually really useful for us, and it's really helpful for when we want to loop through the string and get to the end. When we want to get to the end, that will confirm that we are at the end. So let's try and apply that. Okay, so I've started with writing some code here. So we've just got the standard input-output library included, and then I have a prototype for a function, I've got my main, and then my function. So what function I'm trying to make here is actually strlen. So strlen is a function that you can actually call and use, and it's included in the standard input-output library. But it's not too difficult to make, so we're going to try and make that. So you can see that null terminating character in use. Okay, so the purpose of strlen is to find the string length, strlen. And so the string length is going to be the number of characters in that string, right? Makes sense. So what I've done here is, in my main, I've declared and initialized a string. So to do that, it's pretty similar to a normal array. So you just state the type, which instead of int will be char, because they're all characters in the string, and then the name of your string, which I've just called string, and then you've got brackets for the size of the array, and then I've initialized it to be apple pie. So that's actually the same as saying, I'll just change that, so that equals to apple pie is actually the same thing as this. So A, P, P, and so on. So that's actually the same thing there. Right, so that's what we've got the string as. And then I've just called a printf to print that string so we can see it printed back to us. Then I've declared a length because we're trying to find the length of the string, and then called my strlen. And then I've included a printf so we can see that length being printed back to us. Okay, so what do we need in this function? We're trying to find the length, so we need to, and we actually are going to use that null terminating character because it's, again, really useful for us to figure out when we are at the end, because when we're counting each letter and we want to get to the end. So I'm just going to draw that visually for us. So it's not on my face this time. Okay, apple, and we're all hoping that this fits. Pie. Okay, apple pie. So, as we can see here, the null terminating character is our last element, and we begin with A. So we need a while loop to go through each letter until it gets to that null terminating character. So we want it to be like, so let's imagine that. So we're going to need a counter, right, to keep track of where we are, to make sure we're looping through each element. So since we're trying to find the length, I'm just going to name this length. So we're going to say int length equals 0 because we're turning an integer value, how long it is. And then I'm going to set up the while loop. Do that. Oops. So what is going to be in our while loop? So what are our bounds for our while loop? We want it to go into the while loop when it's just a normal character. So another way of saying that is we want it to go through the while loop when the character is not a null terminating character, because the null terminating character means we're at the end. So let's say while string of length, because that's what we'll be increasing, is not equal to null terminating character. Okay, so now the string should go through each element until it gets to the null terminating character. So just to see that, it'll be like A, is that a null terminating character? No, it's not. Is P a null terminating character? No, you're not. P again? No, you're not. And it'll keep going until it finally reaches the null terminating character, and it's like, hallelujah, we've finally gotten here. Now I don't need to go into this while loop anymore. Alright, so what are we actually putting inside the while loop? I'm just going to get rid of the apple pie just to make the screen a bit clearer. Okay, so what are we actually putting inside this while loop? We're just increasing the length. So we're just going to say length plus plus, which again is the same as length equals length plus 1. So yeah, we're just going to increase the length because that means it'll go to the next indice, it'll go to the next one after that, the next one after that, until finally it gets to the last one, which is the null terminating character. So, and what are we returning to the main? What we found. So we're going to return length, because that's what we want, and that was the purpose of our function. Okay, so now that we've done all that, I will save that, and let's see if it works. So we want it to print apple pie, and then we want it to print how many characters there are in pie, the length of apple pie. So let's try that. DCC, perfect, no errors or anything. Let's run that. So it says apple pie 10. Okay, so let's try and figure out where this 10 came from. How many letters are there in apple? 1, 2, 3, 4, 5. How many are there in pie? There's 3. But then we've got this exclamation point at the end. Is that a letter? Well, it's a symbol, and we can see it, so let's just say it is. So let's say that's 9 characters, and it's like, well, that's not 10. Why is it printed out 10 when I can only count 9 here? Like, as a human, I can only see 9. So take a quick moment to think about that. Yeah. Okay. So it's actually counted the space here. The space in between apple pie counts as a character to see. Which is, different than what as a human we can see. But C can see a lot more than we can see. I've said C too much, I'm sorry. So remember how before I said characters can be lots of different things, including spaces and new lines. So you have to keep that in mind, like kind of just in the back of your head, that like all these different things are actually characters, even though we can't even see them. So if you wanted to just double check that, you can always pull up the ASCII table, which I find quite helpful. And you can see we've got, just our normal letters here, we've got lowercase letters, we've got symbols, and 10 is actually the new line, so LF is actually new line. I can't remember what it stands for, I'm really sorry, but it's easier to remember because it's at number 10. And then it's like, okay, look at all these symbols, and it's, hold on, there's nothing there at 32. Why is there nothing there? It's like, oh, that's where the space is. So space is 32. Also a nice number to remember because it's 2 to the power of 5. Yeah, so it's always good to refer back to that. Yeah, okay. So now that we've gone through that, there's just one other thing that I wanted to address. And so that's just in a normal array when you're setting a length. So let's say I do my hash define my length to be, max length to be 5. And let's put that in there, max length. Okay, so now that we know that, we want it to print the first 5 elements of our array. So I'm actually going to bring apple pie back. So we want it to print out the first 5 elements, right? That's what we've asked, max length. So we want it to print out apple, basically, and have no errors there. So let's see if that actually happens. I'm going to save this. Now we'll get rid of the apple pie again. Let's run it again. Oh, we get a warning. That's annoying. Warning says this char array is too long. Well, you know what? I think I know better than DCC, so let's just run it anyway. Challenge. And I get this big error. Turns out I do not know better than DCC. So we get this huge error, and I've seen this error so many times before, and I remember probably the first 10 times it was like, oh, what is this? What is going on? Why isn't it working? And so this error is called stack buffer overflow, and I'm sure this is not the last time I will see this error. So let's read it and try and figure out what's actually happened. So the DCC explanation says you've accessed past the end of a local variable, make sure your size of your array is correct, blah blah blah, and it says it's actually stopped at line 10. So let's check what line 10 is. So line 10 is actually our printf. So, oh, that's weird. Why is it stopped there? So when we've called printf, we've asked it to print our string, which is here, and the string has a max length of 5. So when it's printing that, it's gone through and it's gone, okay, I can print the A, the P, the L, the E, and then, so it's printed the first 5, and then it's like, hold on, there's more, we've got the space, and we've got the pi, and there's more, but you've only given me a max length of 5, so it's breaking, right? And it's, remember before I said what makes a string is that null terminating character, and there's no null terminating character in the 5th element. It's an E. So it's not a string anymore, and it's just broken. Because it's no longer a string, and you've tried to keep going, even though you've only given it a max length of 5. So if we wanted to see if you actually wanted it, sorry, I've ruined this. Okay. So if we wanted this to actually work, we'd actually have to change this to be APPL, because that 5th element needs to be the null terminating character. So you actually would only print 4 characters, because it won't print the null terminating character. So let's save that and see if that works instead. Oh, and just to clarify, it never got up to length, so length is uninitialized, but it never even got to that point. And see, it printed apple. Okay, so let's get rid of that. DCC. Let's run it. No error this time. Prints apple 4. And that's what we wanted it to do. So yeah, you've just got to keep in mind when using strings, what makes a string is that null terminating character. And as always with arrays, make sure that when you are using a length that it's the appropriate length for what you're needing. That was basically a short-ish introduction to strings. I hope you learnt something new, or maybe just solidified some knowledge, but if you didn't, that's okay. So thank you for listening or watching, and goodbye.